Welcome back, Chem 30. So we looked at that little demo with precipitate formation. Now we'll look at the rest of this booklet. This pertains to pages 292 to 294 of the textbook. What we're looking at here is aqueous solutions, complete ionic equation, net ionic equation, spectator ions, and writing complete ionic and net ionic equations for chemical reactions and aqueous solutions. So after that demo, hopefully this will make a lot more sense. So first of all, aqueous solution, a solution in which compounds are dissolved in water and exist in separated ion form. Precipitate, as you saw there with that yellow precipitate, a solid that forms in a solution. So it's really neat. You have two liquids and then all of a sudden a solid forms. How do compounds exist in aqueous solution? They exist in ion form. And how are precipitates formed? So these are double replacement reactions, and there's a strong enough attraction between one positive and one negative ion such that they form a solid in solution, and that solid is insoluble. So it comes out of solution and just sits as a solid at the bottom of the beaker or whatever we have it in. How does a complete ionic equation differ from a regular equation? The ionic equation has all compounds in ion form except the precipitate. Spectator ions, as I mentioned earlier, do not participate in that precipitate formation. Net ionic equations include just the precipitate and the ions that made the precipitate. And of course the spectator ions are not included with that, they're omitted, because how they were in the reactant side, they are the same way in the product side. Okay, so we'll take a look at an example here. Write complete ionic and net ionic equations for each, given the overall balanced equation here. So we have potassium sulfide, cobalt 2 chloride, yielding to make potassium chloride and cobalt 2 sulfide. Now at this point, I'm simply giving you the information that this is the precipitate. Once again, the lab will do after this. We'll look at that in more detail. So potassium is K+, sulfide is 2-, so that's why we need 2 potassiums for every one sulfide. Chloride is -1, and since I need 2 chlorides for 1 cobalt, that tells me automatically that it's cobalt 2 that I'm looking at here. Okay, so my 2 Ks, my 1 S, my 1 cobalt, my 2 chlorides, so those make up the reactants there, all AQ, all in aqueous form. And 2 K pluses and 2 Cl minuses here, and my precipitate, cobalt 2 sulfide. And then notice here the red lines indicate that I crossed out my spectator ions, those ions that don't participate in the precipitate formation. And then that just leaves you with the net ionic equation illustrating the precipitate and the 2 ions that made the precipitate. Okay? Pause the video right now and you try the next one, 7b. Okay, if you had an opportunity to do that, hydrosulfuric acid, H is H+, S is S2-, bromide is Br-, and since we have 3 bromides for 1 iron, we must be talking about iron 3 and not iron 2. So this the complete ionic equation. In total here, since we have 3 H2S's, every one H2S has 2 hydrogens, but if we have 3 sets, that's a total of 6 H's, 3 S's, 2 irons, and let's see, each iron 3 bromide has 3 bromides, so if I have 2 sets of those, that's a total of 6 HBRs. Or sorry, 6 BRs. Then on the right hand side here, 6 H's plus 6 BRs and Fe2S3. Again, the spectator ions are crossed off, and then that leaves you with just the precipitate and the ions that made the precipitate. And notice 2 irons, 2 irons, 3 S's, 3 S's. So that should still balance out when all is said and done. If it doesn't, something went wrong earlier. Okay, so that's it. We'll look at the vocab here. So first of all, aqueous solution. Solvent is water and solute is dissolved in it. So here's an example of sodium chloride being dissolved in water. Relatively easy. Aqueous means dissolved in a liquid. On the next slide here, using the example, the yellow precipitate, the lead nitrate and potassium iodide, the complete ionic equation shows all the substances in the reaction in ion form except the precipitate. So it's just like how I defined it earlier with the demo. I just pulled that from there. So you can see everything is in ion form except the lead 2 iodide precipitate. The net ionic equation shows the precipitate and the 2 ions that made it. So in this case, lead iodide is made from 1 lead and 2 iodides from over here. Spectator ions, those ions that do not participate in the precipitate formation. So the K plus remained unchanged, the 2 NO3s remained unchanged. Those are the spectator ions. And then lastly, the precipitate, the solid that forms out of solution. So in our case up above, the lead 2 iodide. Okay, so there you have it. That's booklet 10.3. See you again.